Hello, all the esteemed viewers. This is me, Aryan Kumar, and today we are going to cover another crucial topic that is all about 1.2.4. Now, you might get confused. What is this? If you are from any other board, that is okay. You can just take concepts from here. We are going to study all about complex numbers, but at a very professional level with a lot of examples. Now, if you don't know what is a complex number, I would like to recommend you go on my channel and simply search what is a complex number. You can find the first ever video as this topic, that will be 1.1. We will look at how this works and what are its properties. We haven't discussed the further topics or further properties. If you haven't watched again my recent video that was all about few basic properties such as multiplicative inverse, multiplicative property, complex number property, additive inverse, and additive identity, multiplicative identity, distributive property, and there were associative property with addition, multiplication. That was all covered in our recent video. This will all focus upon few conceptual, you can say, problems. Now, our first problem is to identify or demonstrate the properties and solve it accordingly. As we just covered what are properties, again, I will recommend you to go and search through it. Okay, now this is my first problem of today's class. The modulus of z equals to the modulus of minus z, and that is equal to, again, the modulus of conjugate z. Okay, now if you don't know what is modulus, what is conjugate, basically there is a formula for a modulus, or you can say, yeah, modulus, of course. Modulus, that is, let me just write it here: radical a square plus b square. That is my formula for modulus. If you don't know this, again, just go through that video that I just taught earlier. Now, uh, this is focusing all about now, right now, what conjugate. Now, what is a conjugate? Simply inverse sine of any function. Basically, in a inverse function of any sine, or you can say inverse sine of any function, vice versa. That is perfect definition of what is a conjugate. Now, if I write this is my complex number, and if I add a line upon it, that will represent my conjugate. If I don't add this, that will be simply my conjugate. But right here, it is asking us the modulus of a conjugate, and that should be equal to the negative conjugate modulus of z, that is complex number. Now we have to prove these all equations by, like, by time to time solving it. Now, at first, our first ever equation is modulus of z. Okay, now how will I do that? Simply look upon this. Okay, now as you guys know, z is equal to a plus iota b, or b iota, that is called complex number. Okay, now this is my complex number. If I take a modulus of it, and what was the formula? The formula was a square plus b square. Let me just do it for you. Okay, a square plus b iota square, and as you know that b iota square, it stands out to be minus 1. Let me just give a reference here. Iota square is equal to minus 1, as you have might already had studied this in your earlier classes, but at here we are just focusing about complex numbers. Now z should be equal to, again, the same value here, and equals to radical a square plus b square. That is the simple answer. And if you wonder that if it was minus 1, and if I multiply this by minus 1, that would give a minus b. But again, if minus b squares minus b, that will give me minus minus plus. So that is how I solve or derive this equation. Let me just rewrite this for you for a better personification. Let me just do this. Okay. Um, a radical a square plus uh, b square. Now this is my equation number one. And similarly, I have to solve for other equations as well. Let us just do that very quickly. Okay. Um, Now I have not enough space here. I will just do it at upper side of it. Okay. My second equation says the negative modulus of z, that is complex number. So if I take negative modulus, that is minus b and minus a minus b iota, that will simply give me again if it is minus square, and if I do that, that will give me again square a square plus, again the same thing applies here, iota square equals to minus 1. The reference is given below. Okay, and if I do that again, that will give me minus 1 and minus minus plus and plus square again, similar thing, that is b square, or you can say radical a square plus b square. That's my second equation that is being proved at a very minimal point. Now uh, the b and the part number a is done. Now what our part number 3 says, now this is done, this is done. Now this is bit of critical, because this asks me all about the conjugate of complex number as well. Now, if you don't know what is conjugate, let me just tell you. Conjugate means the opposite side. Okay, and if I do that, okay, let me just do that for you. Opposite side of z and modulus of that, and okay, let me just do this. So, first of all, the equation says I have to find a conjugate of it, and you can simply identify and change its sign into minus and do it like this. And similarly, in this point you will have your a square plus minus b, because right here I was having my b iota, you can say imaginary part, as b iota, like imaginary part, if you know. Okay, and again if I multiply that by iota square, that is minus 1, that will give me minus minus plus, and indirectly a square plus b square. Again, sorry, I have just did a mistake here. Minus minus plus and plus and plus, that will again give me plus and plus square, that is again b square. So no big worries, no big problems. Now last and third is find sorry if I did a mistake in this equation. I have to find a conjugate of negative one. Now as we just did that, just suppose this is like positive, and again this is positive again. If I do that, that will give me minus and minus plus. So indirectly that will give me a square plus b square again. That is how simple it is. Now this was the first part of the question in your book, page number 12. You can just go through it and try to understand it by yourself. This was just the thesis by my side. If you like it, you can definitely pursue it. I will just upload a few more videos about this. um, I have triangle inequality as well. I have, you can say, another equation as well. Okay, so I believe after this video, I'm uploading another part. You may check it out. Please, thank you.